So when I joined Cookpad, there was some other person who were writing faster template engine for the Haml template engine language. Haml is just one template engine used by the Ruby community. And at that time, Haml was the slowest template engine that it was I think 6 times slower than Slim or ERB. Slim is also under template engine language, and ERB is a default template engine language. And then because Cookpad was using Haml, they were interested in speeding up, and that person was speeding up the Haml template engine. But because that seemed so cool, I started doing the same thing myself as well. While that person already made a Haml implementation, I made another Haml implementation that's also fast. And there was a bug in my implementation that needed to happen, but I forgot or didn't know it need to be that case. So because of missing that feature, my Haml implementation became slightly faster than the other implementation that they were already developing. And so because of that behavior, because it became as fast as Slim because of that, my Haml implementation got trending in the GitHub trending page, ranked 1 in the Ruby language trending page. And that was when I was almost becoming full-time worker at Cookpad. And then so template engine is kind of like a compiler. You compile, or first you parse the Ruby program, the Haml template language into some intermediate representation you want to work on, and to compile that into Ruby code. Template engine generally compile the template language you want to implement into the host language you want to run it on. So if you want to run Haml on the Ruby language, then you want to compile the template engine, Haml language into Ruby. And so it's a compiler from Haml into Ruby. There, you can speed it up by having a compiler-like pipeline. For example, let's say you have embedded Ruby expression around HTML attributes. And inside the HTML tag, you can, for example, create a string buffer and append static strings bracket HTML, and then append that into the string buffer, and then you embed the dynamic string embedded in the template into the string buffer. And that's kind of like a small compiler where you can pre-compute the combined result. For example, when you have multiple static strings adjacent to each other, then in that case, at the compile time, you can combine these string literals or strings into single string literal and make it faster. So you can do that kind of optimization in the template language implementation. And because of that, I got into interested in optimizing language compilers by doing that kind of transformation of intermediate representation, like static strings and dynamic strings. That was sort of much easier than doing a general programming language optimization, but it still was enough to let me get interested in doing that kind of stuff. And so that was first into developing a template engine that happened to be fast. I later fixed the bug that I found to be the reason why it became faster than the other version. But anyways, I successfully made template engine implementation that's as fast as other implementations like Slim or ERB.